We're now going to continue on with part 3 of notes by talking about electron configurations. So we started talking about this shorthand way of writing things in the last video when I gave new rules. Instead of having to fill all the rooms with a diagram each time, you could just write it out. And we did that with 9 students. So we're going to use that idea to help us here. So this you already have in your notes for phosphorus, the electron configuration. And I'm telling you that the full electron configuration, what you will be expected to write, looks like this. So we have in the 1s orbital, we have 2 electrons. Then in the next energy diagram, each of these arrows represents an electron. So we have 2s2 in the subscript, 2p6 here, 3s2 here, and 3p1, 2, 3 in that last one. So that's what the electron configuration for phosphorus looks like. Then for neon, 1s2, 2s2, 2p6. As simple as that. Now try and fill in this box by yourself. Figure out what element is this based on the electron configuration. So we have lithium, magnesium, aluminum, and carbon. So what would those superscripts represent? What do these superscripts represent? Well, they represent our electrons, and we see it in this diagram here because each of these arrows represent an electron, and what each of those are there as well. So it actually makes sense. One easy way that you could have figured out what element it is counted, since each of these equal an electron, counted how many electrons, and since all of these were neutral, we know however many electrons there are, that's the same number as the atomic number, and that will give us what the element is. So for this first one, for hydrogen, it only had 1 electron, and that's the atomic number for hydrogen. Or this next one, we have 3 electrons. So what, since this is neutral, what element has 3 as the atomic number? Lithium. And I'm just looking at my periodic table of elements. Or if we skip down to magnesium, we have 2, 4, 6, 8, 10, 12 electrons. Since it's a neutral element, what element has 12 as the atomic number? Magnesium is correct. So now, pause the video, write the electron configuration for carbon, then for aluminum, and then the 2 more extra practice that you have on your sheet. So after you filled out the energy diagram, you can look here, and the answer should be 1s2, 2s2, 2p2. And for aluminum, we have 1s2, 2s2, 2p6, 3s2, and 3p1. Make sure that you do those extra practice by yourself. So now we're going to shift gears and do an even easier way. So instead of having to fill out the energy diagram each time, we're going to talk about how you can actually use the periodic table and skip that step. So it's important to notice that on the periodic table, we have different blocks or orbitals. So these are the S blocks, we have the P blocks, the D blocks, and the F blocks. Or here, we see it here, and if we're going to follow along the table, we're going to have a few different steps to take. So if we want to skip the energy diagrams, all we have to do is follow these 3 steps. So first we would find the element, where it is normally listed on the periodic table of elements. Decide what is the address of that last electron. So if it was here, it would be 3p12. So 3p2 right here. And then we would write the electron configuration by looking at what's everything that comes before it. So if we were doing that, 3p2, we would have 3s2, 2p6, 2s2, 1s2, and backwards. So if we needed to write the electron configuration for titanium, we found titanium and would see, okay, that last one is 3d2, except we did have a little bit of a weird rule there, so 3d2 comes before, and then I write everything that comes before it. So we have 4s2, we see that, we have 3p6, 3s2, 2p6, because again we're using this, so this is 2p6. Then we have 2s2 and 1s2. And if we look there, we could have also done it forwards like that. We have 1s2 first that was filled, then 2s2, 2p6, 3s2, 3p6, 4s2, and 3b2. We're also going to talk about how you can even do a shorter one, and this is called the noble gas configuration. So this would be the whole electron configuration, but we could also do a shortcut and find what noble gas comes before it. So our noble gases are, again, what's found in 8A. So in this one, argon comes before it. And then what's everything that came after argon? 3D2 and 4s2. So like to see what noble gas is in the period above the element, write the noble gas in brackets like we saw here, and then write the electron configuration after the noble gas. So for another one, if I were to have the full electron configuration for phosphorus, it would have been 1s2, 2s2, 2p6, 3s2, 3p3. But then all of this first part, 1s2, 2s2, 2p6, represent a neon. That's what came before it. So now I just can write neon in brackets and then everything that came after neon, which was 3s2 and 3p3. So everything in the period below it is written. And really I'm just saying I can just take this out and write neon to represent it instead. Or if I wanted to write the electron configuration for neon, I would have to find the noble gas before it if I'm writing the shorthand noble gas configuration. So helium comes before it, and then everything that's after it is 2s2 and 2p6. You will be expected to do both the normal full electron configuration and the noble gas configurations. Now you have some practice. Write the noble gas electron configuration for sulfur and for magnesium. Pause this video, work on it, and then check your answers. So hopefully you got neon for the noble gas. It would be neon in brackets, then 3s2 and 3p4. And for magnesium, it would also be neon as the noble gas, and then 3s2, but this time 3p4. That is incorrect. Sorry about it. I had the wrong answer there, but for magnesium, you would have neon in brackets, and then 3s2 would be your final address. Do the extra practice by yourself, and we'll check these answers in class. If you have gotten any of them wrong, make sure from the previous examples, make sure you star it, or make sure you go back, review it, and bring your questions to class if you have any. This is now the end of this video. Stick around for the third video as well.